Welcome to Astronomy Daily, the podcast, where we delve into the celestial wonders and the latest advancements that are shaping our understanding of the cosmos. In today's journey across the universe, we'll cast light on revolutionary solar sail technology that has the potential to redefine our approach to space travel. Next, we'll venture to the red soil of Mars, exploring the promising yet arduous strides towards growing food on this alien world. Our quest for answers will then lead us to the icy moon of Enceladus, where mysterious plumes of water ice challenge our imaginations about habitats beyond Earth. Further into our lunar neighborhood, we'll consider groundbreaking concepts that could offer lunar explorers a taste of artificial gravity. And finally, our sights will be set beyond the planetary playground as we delve into the latest innovations poised to change the game in outer planet exploration. Join us as we embark on this astronomical adventure, revealing the frontiers of space science and technology.
The Astronomy Daily Podcast.
In a groundbreaking leap for space exploration, NASA's Advanced Composite Solar Sail System has signaled back to Earth following its launch on April 23rd, ushering in a new era for propulsion technology. As it maneuvers through a sun-synchronous orbit, this innovative satellite harnesses the sun's photon pressure for thrust, bypassing the need for conventional fuel. With the microwave oven-sized CubeSat now healthy and fully operational, the mission paves the way for more sustainable and efficient travel across our solar system. What is truly remarkable about this solar sail is its construction. A composite boom technology developed by NASA's game-changing development program promises to substantially increase the robustness and reduce the mass of the spacecraft. Awaiting its commissioning phase, the satellite will soon deploy its sail that spans approximately 7 meters across, unfurling much like the wings of a bird taking flight for the first time. As we anticipate the real-world data and results from this mission, the implications for future voyages are profound. This technology has the potential to carry us more swiftly and cost-effectively to slingshot around celestial bodies, explore asteroids, and even travel beyond the bounds of our solar system. With each photon-propelled glide through space, NASA's solar sail is revolutionizing our approach to unraveling the vast mysteries beyond our blue planet. As we inch closer to establishing a permanent settlement on the dusty, iron, oxide-rich plains of Mars, feeding our interplanetary pioneers looms as one of the most essential challenges to overcome. Martian soil might bear a striking resemblance to our own barren areas here on Earth, but don't be fooled. Cultivating this extraterrestrial landscape poses its own unique set of troubles and triumphs. Recent Mars agriculture simulations offer a beacon of hope that we might one day farm the red planet's barren fields. The process, though filled with promise, is no easy task. Take a simple intercropping system, peas, carrots, tomatoes. We know them well on Earth. But on Mars, the absence of beneficial soil bacteria means these familiar plants struggle to flourish. The very fabric of life that untangles nitrogen from the atmosphere and feeds it to our earthly crops is missing from the Martian regolith. It's a prime example of how importing our blue planet's practices to another world isn't as simple as interstellar shipping and receiving. Yet there's a silver lining in the less dense Martian soil, akin to our sandy loams. A whisper of home emerges where intercropping surges beyond expectations. Tomatoes thrive, a vivid contrast against the stark Martian backdrop. What's implied here is groundbreaking. We could reform the regolith, optimize conditions, make Mars hospitable at a micro level for agriculture. It's a balance on a cosmic scale. A few nutritious, fresh, and psychologically comforting tomatoes weighed against the cold sterility of engineered astronaut meals. The Martian agriculture simulations are as much about nurturing plant life as they are about sustaining human resilience. Gardening isn't just a pastime. It could be the difference between surviving and flourishing mentally and physically amidst the isolation of space. And so it dawns on us, maybe Mars is not so inimical to life after all. With each simulation, each peep of a pea shoot into simulated sunlight, we uncover more about the red planet's ability to sustain us and our capacity to adapt and thrive in what once seemed unyielding emptiness. This is not merely farming, it's the germination of hope in extraterrestrial soil. Enceladus, a pristine, ice-covered moon orbiting Saturn, holds a warm, salty ocean beneath its frozen crust. a setting so eerily reminiscent of Earth's own aquatic environments that it beckons a closer look. Could this distant moon of Saturn support life? The Cassini spacecraft, during its mission to the Saturn system, uncovered the startling discovery that Enceladus is not as dormant as it appears. Cascading from the moon's southern region, plumes of water are responsible for one of Saturn's rings, indicative of hydrothermal activity below the surface. The secrets of these plumes emanate from what's known as the tiger stripes, 4 parallel, linear depressions that serve as telltale signs of cryovolcanic activity. The dynamics at play here are complex, driven by tidal interactions with Saturn that heat the interior and maintain the ocean in its liquid state. A new study delves into the mechanics behind this phenomenon, uncovering that strike-slip faults, akin to those we've seen with Earth's own San Andreas fault, are integral to the process. These faults behave like cosmic gatekeepers, controlling the ebb and flow of water plumes into space. According to this research, the strike-slip motion does not require vast energies to pry open faults. During Enceladus's orbit, they weave open, releasing subterranean water, then clamp shut, a celestial dance dictating the moon's enigmatic spray. The intermittent plumes peak in intensity in correlation with Enceladus's lunar day, offering tantalizing opportunities for further exploration. Investigations into these fault lines are more than just an academic exercise. They hold the key to understanding the conditions under which life may arise and thrive in extraterrestrial oceans, a testament to the tenacity and universality of biology. Through meticulous numerical modeling, scientists have painted a vivid picture of how Enceladus's subsurface processes could culminate in an environment hospitable to life. These findings underscore the need for continued exploration and observation, as the dance of Enceladus's plumes may sing the chorus of life's potential beyond our blue planet. As we turn our gaze from the celestial seas to the moon dust beneath our feet, a pioneering concept catches the interest of those concerned with our lunar settlers' well-being. Imagine for a moment astronauts running, not in the familiar upright stance as we do here on Earth, but in a horizontal fashion, parallel to the moon's dusty surface, inside what can only be described as a wall of death. Such is the proposal recently spotlighted in a study published in Royal Society Open Science, offering a low-tech yet ingeniously simple method to counter the health risks associated with prolonged exposure to low-gravity environments. Moon-based habitats could incorporate a circular track on their inner walls, reminiscent of velodromes or motorcycle stunts, where gravitational misgivings are met with the centripetal force of a runner in constant motion. Historically, the challenges of muscular atrophy, bone density loss, and cardiovascular decline have necessitated complex, often cumbersome solutions. But this concept, derived from Professor Alberto Minetti's research, is as elegant as it is effective. As astronauts orbit these circular tracks, the increased force could emulate Earth-like gravity, anchoring their health to the celestial body they explore. Indeed, the beauty of this solution lies in its simplicity. While the powerful gravity on Earth denies us the ability to experience this phenomenon without the aid of high-speed motorcycles, the moon's 1/6 gravitational pull could permit such an exercise with nothing more than the astronaut's own 2 legs. Even more compelling, the study suggests that daily sessions within these circular corridors could maintain both physical and cardiovascular fitness while preserving bone mineral status. A feat achieved with no need for the extensive energy requirements of a centrifugal artificial gravity machine. As we continue venturing into the cosmos, solutions that blend human ingenuity with the laws of physics affirm our ability to adapt and overcome the barriers that stand between humanity and the vast expanse of space. With health being central to the success of these missions, such concepts are not just revolutionary, but may be crucial for the sustainability of long-duration space exploration. Our moonwalkers of the future may very well be moonrunners, their feet charting courses along walls instead of flat ground, a humbling nod to our unyielding quest to conquer space while honoring the well-being of those brave explorers. Exploring the remote outskirts of our solar system presents a formidable challenge, one of cost, duration, and reach. But what if we could rethink our approach to spacecraft design, optimizing for these very frontiers? Today, we peer into an exhilarating prospect in space exploration, the science craft. This groundbreaking architecture melds both spacecraft and science instrument into a single entity. By incorporating a quantum dot-based spectrometer directly onto a solar sail, we step away from traditional designs that often limit our ambition due to their bulk and mass. Imagine a spacecraft unfettered by conventional constraints, no larger than a sizable poster, yet potent enough to survey the enigmatic Neptune and its moon Triton. This is what the dedicated team at NASA Goddard Space Flight Center is developing within the NIAC program. Their eyes are set on Triton, an object of fascination due to its retrograde orbit and geologically active surface, to possibly demystify its atmospheric chemistry, ionic composition, and potentially even its internal structure. This science craft proposes to sail across the solar system, propelled by sunlight, leveraging both speed and a broad expanse of area for data acquisition not possible with traditional spacecraft. Not only has Phase 1 feasibility studies shown promise, but Phase 2 aims even higher to catapult this concept closer to reality by addressing technology development and strategic planning required for a future mission. This is a journey not merely by rocket propulsion, it's one taken on the wings of ingenuity and ultralight materials, a voyage that folds space as much as it unfolds possibilities. A successful mission to Triton utilizing science craft could mark a turning point, heralding a new era where outer planet exploration is no longer a once-in-a-generation endeavor, but a prolific chapter in our cosmic odyssey. Now, as we continue to develop and innovate, we prepare to set sail on this solar breeze, hoping to catch the secrets that whirl in the cold, distant reaches of our planetary neighborhood.
The Astronomy Daily Podcast.
As we gaze into the cosmos, the quest to unravel the mysteries of far-off exoplanets, ancient stars, and primordial galaxies has encountered a bottleneck. Current space telescopes are reaching the limits of their observational powers. But what if we could dramatically scale up our celestial eyesight without succumbing to prohibitive costs? Enter NASA's FLUTE project, the Fluidic Telescope Experiment, a groundbreaking initiative aiming to circumvent the limitations of traditional space telescopes by leveraging the remarkable potential of liquid mirrors. This project is poised to catalyze a revolutionary leap forward in space-based UV, optical, and IR astronomy. Instead of piecing together segmented solid mirrors, FLUTE proposes the development of large aperture liquid mirrors formed in the microgravity environment of space. These mirrors would be shaped fluidically, a concept already proven in the controlled confines of laboratory settings, aboard parabolic flights, and even within the microgravity laboratory that is the International Space Station, ISS for short. Imagine, if you will, a primary mirror with a diameter of 50 meters. That's over 5 times larger than the mirrors on the Hubble Space Telescope, and without segmentation. Such a mirror would yield unprecedented clarity and depth in the study of celestial phenomena. The mirror, constructed from specially chosen ionic liquids, requires innovative techniques to enhance its reflectivity, and the FLUTE project is making significant strides in this exacting scientific endeavor through machine learning-driven research and meticulous experimental work. The possibilities that FLUTE unlocks are boundless. A telescope of this magnitude could bring into focus the elusive signatures of Earth-like exoplanets, offering a new lens through which to search for biosignatures or to explore the very earliest structures formed after the Big Bang. Despite the captivating promise it holds, the path to realizing such an audacious project is strewn with technical and engineering challenges. Phase 1 of FLUTE saw extensive research into ionic liquids and the preliminary development of reflective enhancement techniques. Moving into Phase 2, the team aims to refine the mission concept by tackling high-risk elements and pushing forward with modeling, including addressing perturbations caused by maneuvers, temperature variations, and potential micrometeorite impacts on these futuristic fluidic mirrors. It is a venture into the unknown, an attempt to peel back yet another layer of the cosmic onion, revealing the universe's secrets hidden in plain sight by the inadequacies of our current observational equipment. FLUTE isn't just a project, it represents a beacon of human ingenuity, calling out to the pioneers of tomorrow to look further, see clearer, and dream bigger. As we wind down today's episode of Astronomy Daily, the podcast, we've covered a stellar array of topics that weave together the fabric of our current and future space endeavors. From the promise of NASA's solar sail technology to the fascinating look at Martian agriculture, the mysteries of Enceladus's plumes, the pioneering concepts for lunar exploration, and the groundbreaking innovations for outer planet exploration, today's dialogue has truly taken us from the sun-drenched vacuums of our solar system to the potential agricultural grounds of Mars and beyond. Each story today has pulsated with the rhythms of possibility, innovation, and the unwavering quest for knowledge. It's truly an exciting time to be a part of the astronomical community as we watch these groundbreaking studies and projects unfold, further expanding the horizons of our cosmic ocean. For those inspired by today's conversation and eager for more astronomical insights, I encourage you to navigate to our website at astronomydaily.io. There, you'll find a constellation of space news, detailed articles, and the chance to listen to past episodes of this podcast. It's a space enthusiast's haven for continuums of discovery that reach into the deepest pockets of our universe. Thank you for joining us on this interstellar journey today. We look forward to having you with us next time for another enlightening episode as we explore the cosmos and uncover the mysteries awaiting us among the stars. Clear skies and inspired minds to all. This is Anna signing off until our next cosmic convergence.